check on some of the background noise here. Mom, I'm streaming. I said 1:45. All right, sorry about that. All right, so the next question is question number 3, and it asks us to find the integral of sine cubed of x times x dx. Okay, so the junior tutor helpfully laid out some rules that we're going to be using here. So the first rule is we're going to use the trigonometric identities, which is sine squared x plus cosine squared x equals 1. We're also going to use the derivative of a cos function, which is negative sine x. We're also going to use the trigonometric rule of integration of sine x, which is negative cos x plus c. And we're just going to use these rules of integration, which is the sum rule, the identity rule, and the power rule. Okay. So I'm going to be referencing these through the solution itself. And just follow along. If you're unsure of which one I'm using, just look at this. Okay. All right. So the first thing that we're going to do with this integral is we're just going to write it out again. So the integral of sine cubed of x times x of dx. So this is an indefinite integral, so we have to make sure when we calculate it that we have to include a constant c. So the first thing that we're going to do is we're going to use our, we're going to break this sine up into sine squared times sine, and I'll give you a reason why later. So we're going to break sine cubed up into sine squared times sine x times x. Looks like I forgot an x here. Oh, there's no x. Sorry, it's just sine cubed of x. We're finding integral of sine cubed of x, not sine cubed of x of x. Okay, so we break it up in this, and we're going to use our trigonometric rule of identity, which is sine squared x plus cosine squared x. We're going to isolate for sine squared x. So if you isolate for sine squared x, so if this is our rough work here, so this is our identity here, we can manipulate it in a way that we can isolate for sine squared x, which is sine squared x equals 1 minus cosine squared x. Okay. If we sub this into our equation here, we get the integral of 1 minus cosine squared of x sine of x dx. Okay. So now we're going to use a technique called use substitution, which makes the integral that we're calculating a lot simpler to solve for, because this looks pretty complicated to us. We could try to do it, but it's pretty complicated. So we're going to call a variable u and let u equal to cosine squared of x. Oh, sorry, cos of x. Okay, so if we call u to equal cos of x, then we know that du is going to equal to negative sine x d of x. Okay. All right, so we're going to plug, and then if we isolate this further, we get negative du sine x dx. Okay. So we're going to plug in sine x dx and un into our equation here. And if we plug it in, we're going to get this integral here. So it's going to be 1 minus u squared. And sine of x dx is equal to negative du. So now we're integrating in terms of u with a negative sign outside, because we can factor out any constants out of the integral itself. Okay, so now this is a much easier integral to solve. We can break it up using the sum rule of integration. So if we use the sum rule of integration, we get negative integral of 1 du, and we're going to get plus integral of u squared d. Okay. So once we use the sum rule of integration, we can use the identity rule, which tells us that the integration of a constant is just the variable itself. So we can get negative u here. And for this one, we're going to use the power rule, which states that the integral of a power function is just the power function itself with the exponent plus 1 divided by the power plus 1, or the exponent plus 1. So it's going to be u cubed, so it's going to be u squared plus 1 divided by 2 plus 1, which is 3. And this is our integral, our antiderivative. Don't forget to include constant c here, because we always have to assume that there's a constant involved. And this is the indefinite integral, negative u plus u cubed divided by 3 plus c in terms of u, right? So now that we have solved the integral, all we really need to do is sub back in our original function, which is cos x. So if we sub back u in, we get cos x, negative cos x, plus cos cubed x divided by 3 plus c, which is the integral of sine cubed of x dx. Okay. So this is the solution to it, and we use u substitution and all these trigonometric rules and integration rules to find our solution. So this solution is correct. All right, let's move on to